Okay, so this concept that we're going to do is called the irrational conjugates theorem. And it actually has to do with, it doesn't have it on here. It's part of the fundamental theorem of algebra. The fundamental theorem of algebra. It sounds kind of important. So the irrational conjugates theorem is basically saying that if we have a, I'm going to make up numbers. It has letters. If we have a binomial, there we go. A binomial that we have a rational and irrational part to it. Okay, that's an irrational number. If this is an answer, if this is a 0, if that is a solution, then we also will have what's called its conjugate. So if 5 plus square root 6 is a solution, then 5 minus square root 6 will also be a solution every single time. How is 5 plus square root 6 and 5 minus square root 6 the same? How are they the same? Jackson, how are they the same? I'm looking for super obvious answers. How is 5 plus square root 6 and 5 minus square root 6 the same? They both start with a 5. What else? They both have the square root 6. So their first term, exactly the same. Last term, exactly the same. Sierra, how are they different? One is adding, one is subtracting. If you ever have that situation, if you ever have two binomials, they start with the same number, they end with the same thing, but you got 1 plus and 1 minus, those are called conjugates. We call them conjugates. When you multiply these conjugates together, they make a difference of squares. So other conjugates could be x minus 9. X minus 9 could be a conjugate with, well, I will make it the first and the last exactly the same, but what sign should I put in there to make it a conjugate? A plus sign. Boom, conjugates. Okay, those are not irrational ones, but those are conjugates. Okay, so we are going to write a polynomial of least degree that has rational coefficients, a leading coefficient of 1, and zeros at 3 and 2 plus square root 5. So that's a lot of vocabulary here. That's just telling me that we're going to write a polynomial that's going to start with a 1. So there will be no other number in front but a 1. Of least degree means that we will not have any extra zeros that we don't know about. And then the zeros at 3 and 2 plus square root 5 are given to us. So what I'm going to do is I'm going to start with the zeros. X equals 3. X equals 2 plus square root 5. Let's start with those zeros. X equals 3, X equals 2 plus square root 5. We're going to make these into factors. And we were doing this, change them into factors in our past notes over the past week. So for x equals 3, to change that into a factor, we just subtract 3. We get x minus 3 equals 0. So x minus 3 ends up being the factor. So we're just changing these into factors by making it say equals 0. Now, x equals 2 plus square root 5. So what the irrational conjugates theorem is saying is that we will never, ever, ever have just 2 plus square root 5. If there is a square root in it that cannot be reduced, there will be a conjugate. It has to have both. They come in pairs. So if I have x equals 2 plus square root 5, I also have x equals 2 minus square root 5. You can never have the square root 5 by itself. It has to have a pair, always, when we have these. So when we talk about this polynomial being of least degree, I've got one answer that gives me x, x equals 3. I've got one answer that gives me x equals 2 plus radical 5. And I've got a third answer that gives me x equals 2 minus square root 5. So my degree of this polynomial should be 3. When I'm done writing the polynomial, it will start with x to the third. That's what it's going to start with. So that's what the least degree means, is we're just going to use the minimum amount of answers. I could always add more, but it's asking for the minimum. Okay, so we got to make both of these zeros into factors. So I'm going to subtract 2 and subtract square root 5 from both sides. Let's get x equals, not x equals, I lied. I get x minus 2 minus square root 5 equals 0. Same thing on the other one. I'm going to minus 2, and then I'm going to add square root 5. So I get x minus 2 plus square root 5 equals 0. And then our last step is that we're going to multiply the factors together. So I'm going to multiply x minus 3 times x minus 2 minus square root 5 times x minus 2 plus square root 5 together. And to multiply these together, we have 3 things to multiply. And you cannot multiply 3 things at a time. You can only multiply 2 at a time. So we have to pick 2 of these to go with. And what I'm about to say is going to seem like not right, but if you want it to be easy, you always pick the conjugates first. We're going to multiply our conjugates together first. If you want it to be easier on yourself, we're going to multiply the conjugates together first. So you can do that using the FOIL method, or you can make a box. It's up to you. I'll do a box for this one. Or a grid. X minus 2 minus square root 5 and x minus 2 plus square root 5. A couple things to notice when I multiply. I don't like how I wrote this one. When I multiply square root and a number or square root in a variable, I always write the number or the variable in front of the square root so I don't get confused about what's underneath the square root. And then when I multiply the square root 5 and the square root 5 together, that's square root 25, which is just 5. When I multiply square root 5 times square root 5, that's 5. And it's negative because of the negative sign up here. That almost doesn't even look like a negative sign. We'll fix it. There we go. So now I'm going to look for like terms. I've got an x squared, and that is my only like term with itself. So I've used that one. I've got a minus 2x and a minus 2x, and then those are the only like terms with each other, so minus 4x. Okay, then we notice that we have a minus x square root 5. Well, I also have a plus x square root 5, and those cancel each other out. I have a minus 2 square root 5 and a plus 2 square root 5, and those cancel each other out. And then I have this plus 4 and this minus 5, which make minus 1. So when I multiply those together, all of the square roots are totally gone, and we just have a trinomial. And now we have to multiply a binomial and a trinomial together. And again, you can use the FOIL method or you can use the box. I was using the box for this one, x minus 3. And x squared minus 4x. Is it minus 1? Minus 1. Okay, so I combine my like terms, and I'm going to get x cubed minus 7x squared plus 11x plus 3. So what we did, we took the zeros. When there was an irrational, we also included its conjugate. We changed each zero into a factor, 3 factors, and then we multiplied them together. Let's try that again. This one says student practice, which means I would like you to start it on your own. You do not have to finish the whole thing on your own. But I'd like you to start it on your own using our previous example. I mean, but that's nice. is it supposed to be? Okay, so I walked around. You guys were pretty good about getting to this step. You got to find that conjugate, and then you had to set them equal to 0. Then we're going to multiply them together. Oops. After you multiply them together, the terms with the square roots should completely cancel out. And then you collect like terms. And then multiply the 2 factors that are left over. I'll do this one by FOIL. You guys have questions on this? Questions? Okay, and then the rest of that is just one more example. So we're going to go move to 4, 6. Move to 4, 6. And with 4, 6, excuse me, I want to review what we were doing last week, which you guys need your graphing calculator for. Review what we did last week. You can get out your graphing calculator. Oops. So go ahead and type in the equation that is given to us. We're going to type that equation in. What should you do if you didn't bring your graphing calculator? Go to Desmos, DESMOS.com, and type the equation in. Don't just sit here. You need to be bringing your calculator every day. If you did not bring it today, go to Desmos.com. Type in the equation. When I hit graph, it's kind of hard for me to see what's going on around like -3 and -2. So I'm going to zoom in around there. I'm going to change my window by going to the button at the top that says window. And then I'm going to zoom in more around those X's and Y's. So I'm just going to go maybe from like -4 to 1 for my X's. And on my Y's, maybe -2 to 2. Just so I can look specifically around that area. Because now I can see just a little bit better what's going on. So if you can't tell what's going on, you can always use your window to change the way you're looking at it to see better. Sophie, do you have some problems with your calculator? What'd she say? No? Oh, so turn it off. Second on. Okay, now turn on again. I just got stuck. Sometimes they just kind of get stuck. Okay. So when we were doing this last week, the first thing we want to do is look left to right. What 0 do you think we might have? Maybe -3. So to check it, we're going to go second, trace, and we're going to pick 0. Number 2, 0. And then from there, you have to pick a left bound. So if I think it's at -3, maybe I will pick -4 and I will type in -4 and hit enter. Oops. Didn't want me to do that. Because I said subtract 4 because I was using my keyboard. -4. There we go. So I chose my left boundary. Now it wants my right boundary. If we think it's at -3, what could be my right boundary? -2. So I will type in -2 and hit enter. And then finally, I think it's at -3. So I'm going to type in -3 and hit enter. And it tells me, yep, you are correct. -3 is the 0. So we take that over to this page and we say -3 is a 0. And off to the side, I'm going to write x equals -3, and I'm going to make it into a factor. X plus 3 equals 0. My factor would be x plus 3. So I've got a 0 and I've got a factor. Do I need, while I'm doing my synthetic division, do I need any zeros? Or do I have all of the x's? Got all my x's, good. So we do our synthetic division. And if it doesn't end in a 0, then we've done our synthetic division wrong, or we have the wrong number. Because this should end in a 0. We just saw it on the calculator. So if I start with a degree of 3 and I go down 1 power, am I at a quadratic yet? Yes, I am at a quadratic. So once I'm at the quadratic, I'm going to turn it into the equation. So after I turn it into the equation, I'm going to solve it with factoring, complete the square, or the quadratic formula. So this is going to be the equation x squared plus 4x plus 4. And I'm going to solve that with factoring or complete the square or quadratic formula. I will always try factoring first because factoring is the easiest and takes the least amount of time. If it factors, I'm going with that. It's going to be x at x. It'll definitely be plus and plus. Go through my factoring steps. This one does factor 2 and 2. So if we want to write the factored form of this equation, does it start as like an f of x or something? Yeah, f of x. Oops. I will have my x plus 3 factor, and then I will have my x plus 2 squared. So that would be the factored form. And then my zeros. X equals, my first 0 was -3. I didn't actually find my next zeros though. So let's find our zeros. Set x plus 2 equals 0. Solve it. And I get a -2. So my degree is 3. I should get 3 answers, but I only got 2. This is what we talked about last week. When we looked at the graph, what kind of behavior is happening at -2? You can describe the behavior that's happening at that -2, 0. Ella, can you? It looks like a parabola, and parabola means how many solutions will be there? 2. So there is actually 2 answers right here, and they are the same answer. And you can see that from our factoring. We've got 2 x plus 2's. So even though we have 2 answers, we should know we actually had 3. We just have multiplicity. All right, one more, and I have written on here, write small. That must mean it's going to take up a lot of space. Let's go graph it first. Remember, you're using the computer so you can zoom in way far. So when I said write small before, I couldn't do that with paper. It didn't used to work. Bless you. And if you changed your window like I did, you can fix it really easily. You can go back by hitting Zoom 6. Zoom 6 will fix your window quickly back to the way it normally looks. Zoom 6. Where's your calculators? Where's your calculator? At home? Okay. Using Desmos, go. You clicked on them to see where they are. What's it about my shoes? How do you fix this? It's so annoying. I wasn't doing this before this morning. All right. I'm going to look left to right. Where do you guys think there might be a 0? Where? -1, we think. All right, so I'm going to go second trace 0. And I'm going to say my left bound is -2. Enter. My right bound is 0. Enter. And I think it's at -1. Okay, and that confirms it. And you guys, I'm doing this because what if the 0 was actually at -9.74 or -0.974, like really, really close to 1? You're not going to be able to tell. So we are doing this just to make sure. Now, some of you are using Desmos. You'll find that Desmos is so much easier and there is less work to find that 0. You agree, those of you using Desmos right now? The problem is you can't do that for any state testing or assessments, which is why we have this thing that is not connected to the internet. We can use this. So unfortunately, that's why you have to learn this guy. Like ACT, you can't pull Desmos out. They won't let you do that. So -1 is our first 0. We're going to go here and we're going to say -1. Oops. And then we're going to write our coefficients. X to the 5th is 1. X to the 4th is -3. X to the 3rd is 5. X to the 2nd is -1. X to the 1st is -6. And X to the 0 is 4. So I have all of them. I need no zeros. And I do my synthetic division. And it works out perfectly. So we have no remainder. So -1. X equals -1 is a 0. X plus 1 is a factor. Now, we are not done doing this because if I go to my 5th degree and I go down 1 power, I'm only at 4th degree. And I need to get to 2nd degree, quadratic. Right, Genaro? So I'm going to go back to my calculator and I'm going to look at it. And now I need another 0. Does anybody see another 0? 1. Let me double check. So we're going to do second trace 0. So if I think it is at 1, I'm going to check between 0 and 2. I'll guess that it's 1. And that is correct. 1, 0 is a 0. 1. So now what I'm going to do is I'm going to put a box on the end of the one that I just finished. So x equals 1. X minus 1 is a factor. And we have a remainder of 0. So that one worked. I had a 5th power. I went down a 4th power. Now I went down one more. I'm at 3rd power. I'm at cubic. I have to get to quadratic. That means I should be able to find one more 0. Should be able to find one more 0 on this graph. Does anybody find another 0? Pauline, did you find another 0? I see 3 of them. We've only said 2 of them. Nope. That wouldn't be a 0. That'd just be a y-intercept. Ari? There's 2 at what number? At 1, because at the number 1, what's happening to the graph, y'all? It bounces. It looks like a parabola right at 1. That should tell you there's 2 of them here. Because it makes that parabola, there's 2 of them here. Because at -1, it just passed through. But at +1, it bounces. So we have to do one more +1. So over here on the factor, I'm just making it squared because I'm doing another one of those. And it does work. When it works out, I now have a quadratic left. So we've got x squared minus 2x plus 4 equals 0 left over. When we have a quadratic, we can factor. We can complete the square. Ooh, I feel like doing that one. I haven't done it in a while. And we can do quadratic formula. So the first thing I'm going to do is I'm going to try to factor. And then I tried to factor, and it doesn't factor. So you know, I tried to factor, it doesn't factor. So I have to either do complete the square or quadratic formula. I haven't done complete the square in a while, so I'm going to review complete the square. But you could do quadratic formula. I'm not saying you have to do one or the other. To do complete the square, I would do x squared minus 2x plus a square, and then I would move that 4 over, so equals -4 plus another square. And then I would do that middle term. I would do -2 divided by 2 squared. So -1 squared is 1, which I have to add to both sides. Okay, then I would factor it, and I would have x minus 1 squared equals, on the other side, -3. Once you get it to this form, we can square root both sides. If you square root, you have to remember what? In front of the square root? Ryan, what has to be in front of the square root when I take a square root?
Plus or minus.
Thank you. Plus or minus. So now I have x minus 1 equals plus or minus square root -3. Can I simplify the square root -3? Sophie, can I simplify square root -3? How? Yep. So this would be square root -1 multiplied by square root 3. So now we have x minus 1 equals plus minus I, and then square root 3 you can't do anything with. So square root 3. Then finally, let's move that 1 to the other side. And I get x equals 1 plus or minus I square root 3 as those two zeros. Okay, I'm going to zoom it back out a little bit, and we're going to write this in factored form, and we're going to write the zeros. Do factored form first. And was this f of x? What was it? Yep, f of x equals. And then as we were getting our factors from left to right, that's the order I'm going to write them in. So first I had an x plus 1. Then I had an x minus 1 squared because there were 2 of them. And then the last thing that I had could not be factored. The last thing I had could not be factored. So I'm going to write that quadratic right here could not be factored. I'm going to write that as the last factored because it couldn't go any further. So my factored form, the first 3 factors give me zeros. And then the last one, I had to use complete the square or quadratic formula to give me the zeros. We write our zeros. When I write my zeros, I'm going to write those in order from left to right as well. I'm going to have -1, and then I have +1, but there's 2 of them. I don't have to write it twice. And then the other zeros are imaginary, so I'm just going to put those last. 1 minus I square root 3, 1 plus I square root 3. I wrote those last. Where did my purple go? Okay, good review from last time. Last thing we have today, very last thing, complex conjugate. So it's the first thing that we did today, only these are called complex. The other ones were called irrational. Complex conjugate would be something like, they have the first example as 2i and -2i. These are complex conjugates. One's positive, one's negative. If I have 4 minus 5i, its conjugate would still have the 4 and the 5i, but it would have the plus sign in the middle. So it's exactly the same as the stuff that we did at the beginning. And actually, it is completely exactly the same because does anybody remember what the square root of -1 equals? I. So when I write something like 4 minus 5i, it's just like writing 4 minus 5 times the square root of -1, sorry. So it's just like having a square root there, which is what the irrational conjugates were. They have to come in pairs. So when we read a question that says, right, polynomial function f of least degree that has rational coefficients, a leading coefficient of 1, and the zeros at 2 and 3 plus I will start it the exact same way. I'm going to do everything the same. So I'm going to have x equals 2. I'm going to have x equals 3 plus I. And then I have to have a pair with the imaginary number. X equals 3 minus I. Those always come in pairs. They always come in pairs. I will write those as factors. So x minus 2, x minus 3 minus I, and x minus 3 plus I, 0. Okay, and then we're going to multiply those back together. So I know it sounds strange, but we're going to multiply the two together that are more complicated because it will make our life much easier to get these guys out of the way. So I'm going to multiply together x minus 3 minus I with x minus 3 plus I. If you've multiplied correctly, there's an xi and a minus xi that cancel out. There's a 3i and a minus 3i that cancel out. We should have no more imaginary numbers in it at all if you multiplied correctly. What is I squared equal to? That was from our last chapter. What is I squared? Can't hear ya. -1. I squared is -1. So if I have negative I squared, then I have -1. So I have +1. So I'm bring down my x minus 2. And I'm going to multiply that with the combined like terms of this one. So x squared minus 6x. And then 9 plus 1 is 10, plus 10. So from here, you want to multiply those together. You can use your grid method. You can use the distributive FOIL method. It does not matter. I'll do the FOIL this time, just so you've seen me practice both. If you got that one done, try number 5. I'm walking around, see where everybody is. Got that one done. Oh, yeah. You know what? I didn't copy it right. Thank you for somebody staring at it, because then I saw you staring at it, and then I realized I made a mistake. I had it correct above there. I just didn't write it correctly here. There you go. Okay, try number 5 if you got that one. Try number 5. Try number 5 if you got that one. So sorry about my squeaky shoes. Okay, I'm going to work out number 5 without talking so that you guys can try it and like see if you can do it on your own. If you guys have any questions on this, let me know. I'll just leave out my answer. And then you already have assignments. I'm not giving you a new assignment for this. It was kind of, we just didn't finish it last time. So now you can go back and finish. I think it was a worksheet last time, wasn't it? Worksheet. You just couldn't do the bottom of the worksheet. So now you can finish that. All those assignments that have not been checked yet, I think there's 2 of them, because there was half of the book, which I didn't post the answer key for yet. So there was half in the book, and then there was the worksheet. All of that will be due next class, and then we're going to do a scavenger hunt next class. Okay? If the rest of the time, oops. Sorry. I just, when I was multiplying this out, I don't know why I wrote 6. I meant to write 16, and then I copied it over, and that should be a 16 right there. Got that? Sorry, I make silly mistakes when I'm up here talking, and when I do it by myself. I just make silly mistakes.